We're pulling down our injection system for this 3-liter SC engine. Looks like it has a relatively new airbox installed, although they have gone and drilled a big hole in it, something I don't like. We'll smoke test this, make sure it's usable. Then it's just a matter of going through and cleaning things up, getting everything sorted out, changing things like our injector buckets, which doesn't look like they've been out in a while, cleaning all our manifolds, getting all the carbon out, and just setting everything up from scratch to match with our new engine. So somebody's put some money into this side of things, which is good because it'll save us a little bit. Hopefully the box tests okay and isn't leaking all around this. If it is, we can try and seal it up, but not a fan of these. I've seen plenty of airboxes blow up with the toilet seat installed, so it doesn't really make a lot of difference in my opinion. Okay, so I'm working on getting all of our air injection in and hooked up on this engine. Now, one of the problems we ran into is over here on cylinder number 3. And this was the way it kind of was when it came in, where this is all just super tight. Normally these engines don't run this pipe. This is from an earlier car, but he is running SSI heat exchangers on this engine. So here's the original SC pipe. That is supposed to do like this. It fits nicely around all of the air injection. Goes on, no problems. Problem is, we have SSI heat exchangers that now don't fit. So I just spent about an hour and a bit messing around with the pipe because his original pipe was broken for his air injection, and finally got this one in to fit. Now, it wouldn't be a problem if this car didn't have to do emissions. We could remove the air injection and plug it. On a later model, say on an 80 and above SC, not an issue because they don't run air injection. But on these cars that have air injection and still have to use it for emissions reasons, then fitting this stuff is a pain in the butt. Okay, so we finished the underside of our 911 SC. This one's running SSI exhaust, which is a twin outlet. These are more the header style. It had already been updated, or backdated is a better word, when it came to us. We have bead blasted and cerakoted the heat exchangers. They had a lot of oil and carbon buildup in them, and then we just wanted to protect them even though they're stainless steel. So we're looking at our wiring harness for our 79 911 SC, and this one has had a meltdown. So we're going to see what it's going to take to fix it. A couple of other things. That's alternator's not looking too bad. Starter motor is growing some green stuff, and this is how power gets from the alternator back to the battery, is through this main lead here. So we had wires. These are for the heater blower that had been cut. Originally there was a pair of speaker wire running the heater blower fan. So definitely in need of some repairs. I'm just going to assess it and see if it's cheaper to buy a new one or spend the time and try and repair this one. Okay, so these wires here are two of the most essential ones. This one goes to the oil temperature. This one goes to oil pressure. And the strange thing is, these are ground signals. So this measures a resistance to ground. This measures a resistance to ground. There shouldn't have been any power down this circuit at any point to cause this meltdown. But these are unusable in their current state. When you update the alternator, you got to cut out the back portion of the air guide, or you can buy a new one which has this cut out already. And then that just slides on there, and that clears the voltage regulator.
happened.
Yep. I just wanted to see where it was, and it was a half turn off the bottom.
Can you leave the plate in?
Yeah. Okay, so we're gonna smoke test our intake manifold before we start putting it together. I'm not expecting any problems. It looks like it's a relatively new one. One of the easiest ways you can tell, if it's got Phillips head screws, then it is one of the updated intake manifolds. And what they actually updated, just to show you, is down in there, you see this manifold? This is where the cold start injector squirts into. What the problem with the original airboxes was, the cold start injector sprays fuel into this plenum. If you get a backfire through your intake system into this plenum, it will blow or break, separate, whatever you want to call it, the top half and bottom half apart. So what they changed is this spider's leg down inside here. We'll probably see it through here as well. Now we can see part of a metal shield. And what it does is it pushes the fuel into the manifold, so it removes the fuel from this container. Now they can still blow up if you don't start correctly in the morning, so you really want to follow the starting procedure outlined in the owner's manual. And that basically says don't put your foot on the gas in the morning till the engine started. Once the engine started, you can put your foot on the gas. So what we've done here is we've just plugged all of our manifolds. I got some zip ties holding them on. Plugged all of our holes. And what we want to do is put some smoke pressure in there and see if we have any leaks. Now, here's the smoke machine we're using today. So full disclosure, the company Ansell sent us this for free. And we are going to check it out, see how it works. Now, I have another very basic smoke machine, which I have to add shop air pressure to work. One thing I liked about this one is it has its own air pump in there. We filled it up with fluid, and there's a little fluid line right here. It's very hard to see. Not sure if you can see it on the camera. If I wiggle it, you can. Didn't really like the size of the fill hole. They give you this little tiny itty bitty filter to fill it. But also the fluid that I use, which I buy from our supplier, has a little nozzle. So not the worst thing, but if it was me, I'd make this bigger. This is the first time that we have used it. We actually have another job for this later on this week. We have a 911-81 SC that's running rough, and we'll be using it on that. So runs off a 12-volt battery. I've just got a car battery here. Click that on. It's got some fancy lights and stuff. I'm still kind of playing with making the thing work the way I want it to work. Like, for example, I haven't quite figured out how we change this around. But I guess if all else fails, I'll have to read the instructions. All right, so we read the instructions, and currently the pressure gauge is on bar, which I'm okay with. We couldn't figure out how to change it to PSI or KPA, so I'm not too worried about that. I'll play with that side of it later. This here does change my smoke volume flow, so what I'm going to do is just turn the smoke on and let it generate a decent amount of flow of smoke. Then we'll plug it into our manifold and see what happens leak-wise. Now, this will build up to, according to the instructions, 1.2 bar or 17 psi. So we've got smoke flowing right now, which I don't want to do with these caps because it's going to blow them off pretty quickly, and it could also pop our spring here.
Okay.
So we're just going to kind of play it by ear. Let's start injecting some smoke. Well, yeah, we got a pretty good leak out of one of my pieces right there. In fact, it won't build any pressure.
Oh, I'll have to reseal that one.
Wait for it. There it comes.
I see it.
Okay. Let's keep an eye on our pressure here if we start building up. Okay, first thing we have. This is why we hate these. It is just an air leak everywhere waiting to happen.
I wouldn't worry about air pressure.
Yeah, we ain't generating anything.
Snap it.
Alright, we're going to have to play with O-rings. Okay, let's take a look at the box itself. Okay, so our box looks good.
Yep.
There's something right there.
Yeah.
We've got so much smoke in the area, it's hard to tell. We got a little bit of smoke drifting right here.
That's what I thought.
No, it's coming over the top.
Okay. Really, really, really coming out the toilet seat.
Yeah, this is why toilet seat's bad. And if we look at our pressure, we didn't generate anything. So it's just blowing straight through this thing.
Look at it on the camera.
Okay.
Maybe.
Let's see what we can do with an O-ring. Oh, there's half the problem right there.
It's broken and hard.
I think this is a custom make O-ring where you glue them together. But this thing was not sealing at all. Small side. Okay. See if the new O-ring that's in one piece helps. So this O-ring that we had just from our generic O-ring kit is way too small. I mean, the diameter's good, it fits nice, but it's below the surface. So when I feel here, the way an O-ring needs to work to seal is it needs to be able to sit up onto this piece right here.
Is there another ring there?
It looks like actually this is designed to go down inside a little bit too.
You could try it.
No, this is still got to be above here. Let's see if we can find a different thickness O-ring. So the problem we're running into is my O-rings that I have in a generic kit, 4mm roughly. The O-ring that came out of it that somebody looks like they tried to make, and it's been kind of squished, is 4.14. Still really not enough pressure. Another one I had, this one's too skinny, but it's about the same, 3.94. The only O-rings that we have that look like they were close on the cross section is out of a 930 from the pressure pipe, and it is a 5mm cross section, but it's too big to fit in. So this is the problem when we use non-original, non-standard parts. Now I've got to find an O-ring that is 44.5mm on the ID with a 5mm cross section. And because I don't agree with these things, that's going to suck even more because my generic O-ring supplier is going to want me to buy 100 and I need one. Okay, so we spoke to the owner on this one, gave him the options of trying to get another O-ring to go in here, gluing this shut, or replacing the entire airbox and not putting a toilet seat in there. And since we've spent all the time and money rebuilding an engine and we don't want to risk a lean situation that could burn up pistons or valves, we have elected to spend the $600 and replace the airbox, even though this one looks like it's not that old to begin with. Okay, so we have our brand new factory airbox with no 2-inch hole drilled into it. And the way you can tell a late model airbox, if we look down inside, we can see this manifold for our cold start injectors that sprays the fuel straight into the manifold section instead of into the plenum. So we're going to get this assembled up. All of our runners are clean, deburred, polished in where our injector buckets go, and we're just going to assemble it all onto the engine. So far, compared to my other smoke machine, the thing worked really well. Happy with it. Still got to figure out how to change the pressure there, and certainly haven't explored all of the options with it. But generally right now I like it. So we'll continue to use it and see how well it works. Okay, so we're just getting all of our nuts on our intake system. And wiring positioned where it needs to be. So we're just putting our injector buckets in, fresh O-rings, a little bit of silicone grease to slide them down in there, and then we'll re-stake them because we have to polish the stakes out. And this is pretty much key to sealing these things up. These O-rings go rock hard. Make sure those are pressed all the way down. Yep. It's just a blunt chisel. And I just go in the middle of the other punch marks. There's our foam gasket for our sensor plate assembly. And this is so this sensor plate can pop off without drilling a 2-inch hole in the airbox. So I've just cleaned our sensor plate, but right now, sitting on its stop, it is way too low. I'm going to take over the camera on this. Let's see if we can get it. So sensor plate should be, I'm just going to lift this with my fingers, needs to come up so it sits just flush with the apex of the cone. And if it starts down too low, it'll actually have the entire injection range will be too low. As this lifts up, it delivers more fuel. So we're going to go ahead and adjust that before we put it in. Give our spring a little tweak. Oh, needs more. Now normally if we were in the car, we can crack this lock nut off and adjust it. Because it was so far out, it's a little better. I wanted to bend the spring, but I'm going to grab a 7mm wrench and adjust it on the screw. Okay, so adjusting screw on the bottom. And I want to back off the nut some more because it's interfering with my adjustment. Okay, there's my sensor plate adjusted. You can see it best looking at it from that angle.
It looks good. The rusty bolt looks bad.
And then, well, I don't want to change it. It's inconsequential.
How's that lock?
And I'm just going to lock it. Recheck. It looked great. Now our final check on these is this roller bearing down here. You want to make sure that these are free. Now I've just washed this to clean it. And I'll give it a little squirt of lubricant. But when these seize up, they'll actually wear a little ridge in there, and that'll make the sensor plate chatter and give you some weird acceleration stuff. So always want to make sure that that's moving freely. So this area is another common issue where people do the wrong thing and over tighten these springs. These springs are designed to allow the sensor plate to pop off and release excess pressure if there's a backfire in the manifold system. And if they are over tightened and screwed all the way down, won't pop off.
They look pretty squished.
So yeah, I'm going all the way down to coil bind first. And then I'll back them off. Okay, so we're at coil bind. Half, one, half. Half, one, half. Half, one, half. Okay. Nice. We've got new O-ring here, new O-ring there.
Oh, it plugs right into that manifold.
Yep, can't see it.
Oh, I can see in there.
Yeah, but you can't see the injector.
No, it's inside that.
Yep, used to be able to.
Oh, yeah, just in the box, in the plenum.
Okay, there's our cold start injector and our air bypass pipe. Our new O-ring on the bottom of our throttle housing, and I've just washed and cleaned it all out. Then rechecked the adjustment to make sure that the ported vacuum port was closed all the way. This one was actually up a little bit high, and when I pulled it apart, the air bypass screw, which goes in here to adjust the idle speed, was actually almost all the way in and seated. So we're going to just go ahead, sit that on. This is our idle control air bypass screw. We're just going to screw it in and bottom it out. Now originally this one was only like a 3/4 of a turn out. I usually like to start around 2 turns. Half, one, half, 2. Let's go an extra half just because. Okay, so we've got our auxiliary air slide. This is auxiliary air for when the engine is cold. We've already checked it on our test bench, and to check it all you do is apply 12 volts power. It doesn't matter which pin, and if you look down there, wait for it, that little valve will close if it's working correctly. It'll take about 180 seconds or so, and it may not close 100%. There may be a little tiny hole in there, but really simple. These give us very little problems. So we're just going to plug that in. Actually, we're not, because I won't be able to get to the bolt, but we are going to connect the hose to it. Actually, let's flip the hose clamp around, so if you ever have to do this in the car, you're not cursing my name. Let's go ahead and rearrange our wire a little bit. That one's in. Let's put that up that way. That one in. And our final one over here. Just in case somebody wants to try and do this in the car. This one, you're not going to have any chance. Warm-up regulator, we've got a line that we got to replace. Okay, so this is the piston out of our fuel distributor. We just want to make sure that there's no scoring. I usually put just a little tiny bit of very lightweight lubricant. So it should slide very, very freely. Should be no tight spots. Just using a magnet because it's easy to do. The other thing you got to watch is when you put it onto the fuel distributor, you got to be careful that, onto the sensor plate, that it doesn't just fall out. So make sure your O-ring's on, and then holding it locked into the housing. Just making sure our sensor plate lifts normally. Now, I don't normally like to disturb these. You got to be careful when you take these bolts off. It looks worse than it is. We'll
put some lamp space on it.
Yep. Give it a little bit of lube. So if you touch this plate and you pull it off, you've got to be very, very careful about recentering it in the housing. That's why I don't like to touch them if I don't have to. The bolt looks worse than it really is. From a running standpoint, there's no issues, but you don't want to touch this stuff unless you absolutely have to. So I'm replacing vacuum hoses. This one rock solid. So this one goes like this. These hoses are still in good shape and are kind of unique. They're nice and soft and pliable, haven't turned rock hard. But stuff like this, we want to change.
It's another crunchy hose.
Tap it. Squish, squish.
Oh, I can't squish it.
You need thumbs of steel.
I have.
So we also have these other ones. These are not as bad, but we're still going to change them just because they're getting just really crusty and hard. Always a good idea to look at this stuff. That's why we're going to rebuild it, because there's no way that would move.
Really stiff.
Try and move it.
I don't have thumbs of steel.
Not that part, the outside part. No, you'll try.
Oh yeah, I got it. But it's like a kind of jammy feeling.
Guaranteed to kill your CDI and coil. Okay, so I'm checking our resistance all the way through all our plug connectors, and what the problem is. Baru changed their manufacturing quite a while ago now, over 15 years ago. They changed these plug connectors, and these are supposed to be a 1 ohm connector, and it screws onto the ignition wire like so. Let's take the boot off. And what the problem we have with them is dimensionally this size is too big to fit into the cap, and it doesn't always make it all the way down to the electrical contact in there, which you can't see anyway.
Okay. There it is.
There it is. So I found 3 out of 6 wires open circuit, which means there was no connection from the cap to the spark plug wire. Nothing wrong with the wire or the connectors. The problem is that isn't in deep enough. So to fix it, I need to take a ream, and I need to ream the cap and I got to get all the way down.
Without hitting the connector.
So now I can actually plug the connector in and have it contact the brass instead of getting jammed at the top. This is the stuff that you can't charge enough for, because yeah, I could build the best engine in the world and the thing is not going to work because it's going to kill the CDI and the coil in a very short amount of time. There's so many problems with the electrical parts today. You can't buy the correct rotors. You have to run a different resistor, so you have to change the resistor on the coil wire, which we'll do in a little bit, because Bosch discontinued the correct rotor for this car and superseded with one that looks exactly the same but has a different resistance value. So all of these items combined, for those of you that have killed CDI boxes every 18 months and you can't figure out why, problem is you have a lot of compounded issues where spark energy cannot make it through to the spark plug and burn, and so it ends up going back through the system. So simple job that should have taken 5 minutes, got an hour in it. Okay, to compensate for the ignition rotor, we use a 5K resistor. You can buy these from Parts Classic. And normally the ignition coil wire comes with a 1000 ohm resistor on it. And because our ignition rotor is now 1000 ohms, we need to get back our 5000. So we change the resistor and we have 5.19 thousand ohms. So electrical tolerance plus minus 10%. If you don't do that, this little part right here, if you leave the original one, will kill the ignition coil and or the CDI box too. Okay, so this is very important with cars that run shielded wires, and this is only 6-pin CDI cars, so 78 through 83 911SC, and 75 through 94, I think it is, turbos. If you don't have this shield right here, this wire can touch on the coil. This side isn't a big deal because it's ground, but this side is the A terminal, and it will ground out the ignition coil. So you want to make sure you have that cap installed.
Great.
So we got all our wires on, our little holders in. There's a holder in here, connects here, across the fan shroud. These are important to stop them moving around. They're not just there because they look pretty. It's there to actually hold them. So we're about almost ready to wrap up this job. Okay, so we're putting on our V-belt, and now we have evolved. For many, many years I would use the Kentucky belt, but that is actually not the best belt you can use. The Porsche belt is specifically designed for a shiv type pulley where it's adjustable, whereas the Kentucky belt is designed for a fixed V pulley. So it does make a difference. And this is the wrong size belt. This is a 725.
Oh yeah.
Because I'm all the way in.
So what's the right size belt? 825?
710.
710.
Now we've grabbed the right belt. The problem is when you have multiple belts in stock. Okay, so we've got our V-belt on. This is about the tension that we're looking for. About 5 to 10 millimeters of deflection. And you want to have it so you can read Porsche outwards. The reason for that is not just in advertising, but if you ever take the belt off for whatever reason, let's say you need to change a pulley or something, you need to put the belt back on the direction of travel. So if you always put the writing facing out, that just is the way that I do it. So I know that if I have to take the belt off after it's run and put it back on, then I know which direction it goes. Reversing the belt can shorten its life because it does take a set based on the direction it's run. New belt doesn't really matter, but it's just good practice. Okay, so that's pretty much it. A couple of things we're waiting on is new muffler
Yeah.
down here. So I've still got this loose so I can adjust it, so I'm not going to put my engine hanger on until I got my muffler on and tighten these. We're also waiting for a new CIS air boot across the top there. But all of our ignition is done. Ignition distributor is rebuilt. It had a couple of problems. It was the vacuum advance module was all seized up and was not, the vacuum module could not move it. I could barely move it with my fingers. The weights weren't too bad, but we completely disassembled. We removed the fiber thrust washers because they always break, and replaced them with a brass thrust washer, reshimmed everything, set up the end float, cleaned and lubed all of our weights, fresh springs, and then we ran it on our distributor machine, making sure that it was hitting all of its timing points. The vacuum retard module was hitting where it's supposed to be. So fuel injections all on, cleaned up, all fresh vacuum lines, rerouted to correct places. So now once we get our last couple of parts, hopefully in the next day or so, we'll be able to get this engine off the stand and onto our engine run stand and fire it up. Okay, Euro muffler strap with a stock Dansk muffler. And I'm using a BMW head bolt, which is extra long to pull it in. This is the bolt that they supplied. This bolt is 10 by 40. Porsche says 10 by 50 should be the bolt size. Right now, 10 by 40, if I hold it up, doesn't even go into the thread. Another 10 millimeters would be barely into the threads. So not only is the bolt too short, the strap's too short. What to do from here?
Cut down the head bolt. Use it.
No, can't do that. I'll just see if I got a 10 by 50 hex head. All right, so we've got the last of our fuel lines installed and our airbox is all hooked up, and this engine is done, ready to go on to the test stand next.
So underneath here is a polyamide fuel line, and it has just gotten so brittle that I touched it and it's breaking. So I'll have to see about replacing it.
Now I'm going, oh, grab a rag. That's bad.
generator lights out. Whoop, wasn't me.
Switch it off for ignition and fuel.
Press the start button.
Oh. Ready?
Yep. Let it get some temperature in it. When I started it out, look at the hydrocarbons, even at overrich, 200.
Nice.
Look at the CO2, 12.3. Awesome. Hydrocarbons, 180. And it's still too rich. This right there now,
Nice.
158 hydrocarbons, it's burning everything, it's putting it in. Oxygen count, 1%, awesome. CO2, almost 13, awesome. Lambda, 0.96, slightly rich for an idle, which is what it should be. God, the oil pressure moved. No, that's really nice. That's really good.
I like it.
Our numbers are doing really good. We got about 30 minutes of run time. 138, 140 hydrocarbons means it's burning everything that's we're putting into it. 1% O2 means that we're not overly rich or overly lean. There's still a little bit of oxygen left in the exhaust. CO 2.5%, exactly where I want it to be. Lambda 0.96. 1 is perfect, but you'll only see that on cruise. We want to see it a little hair on the rich side at idle. And CO2, this number, the longer we've been running, the more it's increased. It started at 11.8, now we're up to 13.12, so that means the engine's starting to settle in. Now we can't bed rings on this test stand. This is more, allows us to set timing, set basic fuel, check for oil leaks. The car still needs to be bedded correctly, but so far everything's looking really good. 62 degrees C, so not up to full operating temperature, but hot enough where we can shut it down, let it sit, and then do a restart.
You gonna shut it? just wait how long?
20 minutes.
Okay.
Okay, hot, restart after 15 minutes.
So tomorrow?
Okay, we got to cool it down and redo our cold start tomorrow morning. Okay, so we're going to do our cold start now that we've made all of our timing and mixture settings. We're at 16 degrees C and see how it works.
Not so happy.
Got to turn the fuel on.
Oh, let's start again. Oh, that sounds better.
Yeah, much happier. That could have been better, could be created and make